Hello, boys. Good morning. We are in our review class, and we have already reviewed the chapters for once, but as we have enough time before our second round in-house test, so we will try to have some review again, and we will just try to start from chapter 1. Chapter 1 was physical quantities and their measurements, and all of you know that the contents of these chapters includes different kinds of physical quantities, derived quantities, fundamental quantities, their measurement technique, some suffix, their usage, and then in case of instrumental or measurement case, we have known the use of slide calipers and screw gauge, and some mathematical terms related to this instrument. So in review class we will just discuss some creative questions again. So let's start the class. Question number 1. After putting a bar in the slide calipers, the reading of the main scale is 4 centimeter, point of coincide of the vernier scale is 7, and vernier constant is 0.1 millimeter. By recalibrating, the 20 divisions of the vernier scale is said to be equal to the smallest 19 divisions of the main scale. This is our stain, and what are the questions related to this one? First one is, what is absolute error? Second one is, what is meant by Vernier coincidence is 7? That means if the Vernier coincidence is 7, what is meant by this term? Find the length of the bird. Question number 3, find the length of the bird. And question number D, with the change of number of divisions in Vernier scale, what will be the change in the length of the bird? So these are the questions according to the following stem. If we just have a look on the stem again, we are just trying to measure the length of a bar using a slide calipers, and a main scale reading is 4 centimeter. Vernier coincidence is 7. Vernier constant, in the first case, Vernier constant is 0.1 millimeter, but when the scale is recalibrated again, so this is quite usual that the Vernier coincidence or Vernier constant will be changed here. So we will count the fact during doing the while we just complete the math. So what is the answer of question A? What is absolute error? Absolute error is the difference of the measured value with its actual value. For example, if we just are trying to measure the gravitational acceleration g, small g, we know its standard value is 9.8 meter per second square, but in a lab, if we are measuring the value, and if we get the value is 9.7 meter per second square, that means the measured value is changed from its actual value, and that change or that difference is called the actual error, absolute error. So absolute error is the difference between the measured value with the actual value. Okay, then question number B, what is meant by Vernier coincidence? Here as I have written this actual error, that this term will be absolute error here. Just make a correction here, so this will be absolute error. Question number B, what is meant by Vernier coincidence is 7. Vernier coincidence, we know this term, that is while we are measuring any length of any instrument, we use the slide calipers. Then there are two scales, one is main scale and Vernier scale. Then if the Vernier scale, any mark of the Vernier scale matches with the any mark of the main scale, that number of Vernier scale is called the Vernier coincidence. So as here the Vernier coincidence is mentioned 7, it means that if we measure from the left side of a caliper, then the seventh mark of the Vernier scale coincides with any of the marks of the main scale, or if there is no coincidence, there is no superposition between Vernier scale and main scale, on that case we will consider the very close mark of Vernier scale to a main scale. If there is exact coincidence, we will count that one, but if there is no coincidence, then it will then we will just consider the very close mark of main scale to the Vernier scale. So this is the question number B. What is meant by Vernier coincidence? C. And our question C is find the length of the verb. We have to determine the length of the verb here. What is the length of the verb? As we know, the equation for measuring length using slide calipers, that is L equals m plus v into vc, where m is main scale reading, v is Vernier coincidence or Vernier superposition, and vc is Vernier constant. All the terms are given on our question. Main scale reading is 4 centimeter, Vernier's coincidence is 7 as it has no unit. Vernier constant is 0.1 millimeter. We will convert it into centimeter. Then after putting all these values on the equation, L equals m plus v into vc, we just get the result length is 4.07 centimeter. This is the length of the bar using slide caliper and using the given value of the question. But in our question it was mentioned that the scale is recalibrated again, and on that case if we just look at the stain again here, the scale is recalibrated where the 20 divisions of the Vernier scale is said to be equal to the smallest 19 divisions of the main scale. So as the scale is recalibrated, we have to measure the Vernier constant again here. So what was the question number D? With the change of number of divisions in Vernier scale, what will be the change in the length of the bar? With the recalibrated scale, what will be the new reading for the length? Let's just try to determine the question number answer of D. As 20 divisions of Vernier scale is equal to 90 divisions of smallest main scale, smallest unit of main scale, that means smallest unit of main scale is millimeter. That means 20 divisions of Vernier scale is 19 divisions of main scale. That then we can determine from this, one division of Vernier scale will be just equal to 19 divided by 20 division of main scale. As the smallest division of main scale is 1 millimeter, then we can find that one division of Vernier scale will be 19 divided by 20 millimeter. So for this recalibrated scale, what will be the recalibrated Vernier constant? The recalibrated Vernier constant will be, as we know, the definition of Vernier constant is the difference of smallest one division of main scale and Vernier scale is called the Vernier constant. So from our assumption, we have known that one division of Vernier scale is 19 divided by 20 millimeter, and we also know that smallest one division of main scale is 1 millimeter. So their difference is the Vernier constant, that is 1 minus 19 divided by 20 millimeter, and in millimeter scale this will be 0.05 millimeter, and if we convert it into centimeter, it will be 5 into 10 inverse 3 centimeter. So this is the recalibrated Vernier constant. We can also determine the Vernier constant by our regular equation, that is the Vernier constant is equals smallest one division of main scale divided by total number of scale on Vernier scale. So here we will get the same result using that equation. That means B is equals S divided by N. Using that equation we will get the same one, but we have used this one because in the question it was mentioned that the scale is recalibrated. So we have used the this process for measuring the recalibrated Vernier constant. So we have got the Vernier constant here, and then we can measure the altered length. A question may arise here that as the scale is recalibrated, so this is quite usual to have a change on the Vernier coincidence. This is natural to have a change in Vernier coincidence, but as in question anything is not mentioned about this fact, so we will count the given values that we have used for the question number C. Using those same values, we will just determine the altered length again. Altered length L prime is equals, the equation is just as before, m plus v into vc Vernier constant, as this is a altered or recalibrated Vernier constant, we are just using as vc prime. Then after putting the values here, we just get the altered length 4.035 centimeter. So as the scale is recalibrated, the length of the burr is changed and the new length is 4.035 centimeter. So the total change is length is as from C we got the length was 4.07 centimeter, and from D we have just a new value 4.035 centimeter. As the scale is calibrated, so this is quite natural that the we will get a more precise value using the same scale. That is the difference between two length is 4.07 minus 4.035 centimeter, that is 0.035 centimeter. So as in question, the Vernier constant was given 0.1 millimeter. From this term we can guess that the Vernier scale was of 10 divisions, and so for that scale, what was the value of using that scale was 4.07 centimeter, and while the Vernier 20 divisions Vernier scale is used instead of 10 divisions Vernier scale, the reading will be more close, more precise, more clear, and then we just get the value is 4.035 centimeter, and the change of length is 0.035 centimeter. So this is our desired answer for question number D, and I hope all of you have understood this one. And now we will just try to solve another question. Question number 2. This is also related to Vernier scale or slide calipers. This is about question. What is the stem over here? The Vernier constant of a slide calipers is 0.01 centimeter. Diameter of a sphere is measured using these calipers. The main scale reading is 12.2 centimeter, and Vernier coincidence is 5. There is no instrumental error in these calipers. The mass of the given sphere is 1 kg. As we know that there are two kinds of errors in case of a Vernier scale or slide calipers: positive error and negative error. As there is no instrumental error, we have no need to think about that. If the error was given, we had to count that, but as there is no error, we won't think about the error. The mass of the given sphere is 1 kg. Here we will discuss just only question number C and D. What is question number C? Determine the radius of the given sphere. And question number D, the sphere will whether sink or float in water. Explain mathematically. The in question C, it is told to us to determine the radius of the sphere. As we know that for determining radius we can use screw gauge, and that gives us more exact values, more precise values. But as in the STEM it is mentioned, we have to use slide calipers, so we will determine the radius using slide calipers. So for measuring the value of the radius, at first just we have to put down all the values. We have to mention all the values according to their units. Here the main scale reading m equals 12.2 centimeter, Vernier coincidence is 5, and Vernier constant is 0.01 centimeter. Then sphere's diameter, the same law, same equation again, d equals m plus v into vc, and putting the values here we just get the sphere is 12.25 centimeter. We have just taken the values in centimeter, and we haven't made any change here, so we will get the result in centimeter. Then what was question number D? The sphere will whether sink or float in water. A sphere will sink or float in water. That will depend according to the buoyancy rule. We know that if the mass of the body, if the mass of the object is more than the water displaced by it, then it will sink, or if the mass of the body is less than the displaced water, then it will float. So at first we have to determine the displaced water by the object. So for that we have to determine the volume here. Here the radius is given 6.015 centimeter. Now we will convert it into meter, and that will be 6.125 into 10 inverse 2 meter. The mass is given 1 kg, and from C we have determined the diameter is 12.25 centimeter. So dividing it by 2, or just making it half, we get the radius is 6.125 centimeter. So what will be the volume of the radius? And this is a sphere. We will just use the law for a sphere, that is 4 by 3 pi r cube, and here r is 6.125 into 10 inverse 2 meter. Putting this value in the equation, we just get the volume is 9.625 into 10 inverse 4 meter cube. So we have determined the volume, and so now we will determine the amount of displaced water for this volume. As we know, the density of water is 1000 kg per meter cube, and if the density of an object, by the density of object we mean that we know the equation for density, rho equals m divided by v kg per meter cube. That means for per meter cube displacement, for per meter cube space, for per meter cube area volume, we just get the amount of mass, that is the density. So as the density of water is 1000 kg per meter cube, that means for 1 meter cube water the mass is 1000 kg. For 1 meter cube water the mass is 1000 kg. Then for the mass of 9.624, as the mass of 1 meter cube water is 1000 kg, then as we have determined the volume 9.625 into 10 inverse 4 meter cube, what is the mass of that amount of water? That will be 1000 into 9.625 into 10 inverse 4 kg. So finally we get the mass of total water is 0.9625 kg, and this is the amount of water displaced by that object. So we just know from the saying sphere's mass is 1 kg, and the quantity of displaced water the sphere's mass is 1 kg, but the quantity of displaced water from our calculation we have found that the quantity of displaced water is 0.9625 kg, that is less than the sphere's mass. So if the object's mass is greater than the displaced water, then the object or body will sink or drown on the water. So for this case we just say that the object will drown. So this is our second question, or second creative type question in our review class for chapter 1. um, we are reviewing the chapters again, and we hope that you are also doing your revision repeatedly after finishing for a single time. You will just review the terms again, and you, if you have any kind of problem, all the problems will get clear to you if you just review your chapters for several times. So guys, this is our review class for chapter 1, and next class we will try to review on some other chapter. And till then, goodbye, and stay safe, and be attentive to your study. Okay, goodbye to all.